Hello everyone, I am Miss Priyanka Sanjay Latte, lecturer at More Education Society's Munarular Institute of Pharmacy Sonic. In this presentation, I am going to discuss topic that is adulteration and drug evaluation. Part first. This topic we will discuss for first year D Pharmacy students. Content of presentation. Definition. Methods of adulterating the drugs. Drug evaluation. In this presentation, we will discuss the two methods of drug evaluation. In that first, the organoleptic is also called as morphological or external evaluation, and second one, microscopic evaluation. Firstly, we will discuss definition. First definition, adulteration. It is a debasement of an article, that is mixing of adulterant into the original drug or genuine drugs. This mixing of adulterant is called as adulteration. Second definition, adulterant. The substance which are similar of original drug with respective morphological characters, but it contains less or low active constituents is called as adulterant. The next point, methods of adulterating the drugs. Adulteration depends upon whether the drugs is indigenous or obtained from other countries. Adulteration is very common with drugs which are sold legally. It involves different conditions such as impurity, spoilage, deteriorations, admixture, sophistication, and substitution. The first, inferiority. Inferiority refers to any substandard drugs, whereas spoilage could be due to attack of microorganisms. Second, deteriorations. Deteriorations means impairment in quality of the drug. Third, admixture. Admixture, it is the addition of one article to other through ignorance, carelessness, or an accident. Fourth, sophistication. Sophistication means intestinal or deliberate kind of adulteration. Fifth, substitution. Substitution occurs when an entirely different article is sold or used in place of one required. The different means for adulterating drugs are as follows. First one, replacement by existed drugs. This type of adulteration is generally observed in costly drugs. For example, clove, saffron, tea, fennel, ginger, etc. These drugs are adjusted for their active constituents and reused with genuine drugs after proper treatment. Adjusted saffron is colored artificially while ginger is mixed with starch and colored to produce proper shade. The fictitious nutmegs are made from mineral matter pressed into molds and flavored. Second, substitution with superficially similar but inferior drugs. The drugs which has not reached minimum standard of quality is called inferior drugs. The common example of substitution is adulteration of clothes by mother clothes. Saffron is adulterated with dried flowers of Carathramus tinctorius in bracket safflower bracket complete. Digitalis containing leaves containing higher percentage of glycosides. Third, substitution by artificially manufactured substituents. This type of adulteration is observed in case of drugs which are costly. Paraffin wax is tints yellow and substituted for yellow beeswax, while artificial invert sugar is mixed with honey. Fourth, substitution by substandard commercial varieties. In this type of adulteration, the drug which have minimum standard as compared to genuine drug or originated drug are mixed with original drug. The substitution of Alexander senna with Arabian senna and substitution of rhubarb with many species of rumex are other example. Nux seed in bracket Trichomes nux bracket complete are adulterated with Trichomes nux blenda or Trichomes potatorum seed. Fifth, presence of organic matter obtained from same plant. In this case, advantages of similar color, odor and constituent is taken into consideration and other parts of the same plant are added to genuine drug. Example, cloves are mixed with clove stalks, while caraway and ananthum fruits are mixed with other parts of inflorescence. 6. Substitution by synthetic chemical substance. Many times a synthetic chemical which constitute one of the chemical constituents of the drug is added to the genuine drugs. Example, benzyl benzoate to balsam of Peru and citral to oil of lemongrass and camphor oil and eucalyptus oil in oil of rosemary. Several times, wastage from the market are collected and admixed with drugs. This is observed in case of unorganized or liquid drugs. The pieces of amber-colored glass in colophony, lime tones in asafoetida, white oil in oil of coconut and styrene or paraffin in coca butter are deliberate kind of adulterations. Next point, drug evaluation. Evaluation of a drug means confirmation of its identity and determinations of its quality and purity. Several methods are used for the detection of adulteration for genuine drugs. First method, organoleptic, is also called as morphological or external evaluation. Second, microscopic evaluation. Third, physical evaluation. Fourth, chemical evaluation. Fifth, biological evaluation. We will discuss one by one. First method, organoleptic, is also called as morphological or external evaluation. In this method, good drugs is evaluated by morphological in bracket external bracket complete characters such as color, odor, taste, size, shape, structure and features. First, color. Some drugs become pale green when dried in sunlight. Example, green leaf become pale green. Second, odor. Some drugs have characteristics odor which helps in identification of drug. Example, aromatic odor of umbelliferous drugs. For example, phenol. Third, taste. Some drugs are evaluated by its characteristics taste. Example, sweet taste of licorice. Fourth, shape. Disc shape, structure of Nux vomica and conical shape of aconite. Then second method, microscopic evaluation. In this method, drug is evaluated by using internal characteristics of good drugs. In this type of evaluation, microscopic characters of organized good drugs are identified. The microscopic evaluation also covers study of constituents by application of chemical test to small quantities of drugs in powder form or to histological section of the drugs in bracket microchemistry bracket complete. Histological studies are made from very thin section of the drugs. The characteristics of cell wall, cell contents, trichomes, fibers, vessels, etc. can be studied in details. Example, signified trichomes in Nux vomica. The following few constants illustrate the importance of microscopic measurements. First, stomatal number. It is the average number of stomata present per square mm of the epidermis, that is midway between midrib and margin. The actual number of stomata per square mm of leaf preparation may vary for leaves of the same plant grown in different environmental conditions. Stomatal number is relatively a constant for particular species of same age and hence it is taken into consideration as a diagnostic characters for identification of a leaf drug. The adulteration can also be detected by stomatal number. It can be further illustrated by following examples. Stomatal number of few leaf drugs. In that first, the species Dhatura stramonium stomatal number is 087. upper epidermis. Second one, species Datura inoxia, stomatal number 141, upper epidermis. Third one, species Hyosamus niger, stomatal number 125, upper epidermis. Second, stomatal index. It is the percentage which the number of stomata from to the total number of epidermal cells, each stoma being counted as one cell. It can be calculated by a formula. I is equal to S into 100 divided by in bracket E plus S bracket complete, where I is equal to stomatal index, S is equal to number of stoma per unit area, E is equal to epidermal cells in the same area, stomatal index of few leaf drugs. In that first, species Atropa belladonna, stomatal index in lower surface 20.2 to 23. Second one, species Atropa acuminata, stomatal index 16.2 to 18.3. Third, species Indian senna, stomatal index 17 to 20. Fourth, species Alexandrine senna, stomatal index 10.8 to 12.6. Then third, Venn isolate number. It is the number of Venn isolates per square mm of leaf surface. It is a constant for a given species of the plant. When illustrates the Venn isolates number, the serial number first, species is digitalis purpura and Venn isolate number 8 to 12. Second one, species digitalis thapsi, Venn isolate number 8.5 to 16. Third one, species Cassia angustifolia, Venn isolate number 19 to 23. Fourth one, Cassia acutifolia and Venn isolate number 25 to 30. Then next fourth, palisade ratio. It is the average number of palisade cell beneath one epidermal cell using 4 continuous epidermal cells for the count. Since the palisade cells in the mesophyll of the leaves bears a definite relation to the epidermal cell, in that some species illustrated by palisade ratio. In that first, the species Atropa belladonna, palisade ratio 6 to 10. Second one, Datura stramonium, palisade ratio 4 to 7. Third species, digitalis purpura, palisade ratio 3.7 to 4.2. Next fifth, quantitative microscopy in bracket Lycopodium spore method. It is an important analytical technique for powdered drugs, especially when chemical and other methods of evaluation of good drugs fail as accurate measures of quality. Lycopodium spores are very characteristic in shape and appearance and expectationally uniform in size, that is 25 micrometers on an average. 94,000 spores per mg of powder Lycopodium are present. A powdered drug is evaluated by this technique if it contains first one, well-defined particles which may be counted, example starch grains or pollen grains. Second, single layer cells or tissues, the area of which may be traced under suitable magnification and actual area calculated. Third, the objects of uniform thickness, the length of which can be measured under suitable magnification and actual area calculated. Lycopodium spore method can be used for evaluation of powder clove, ginger, cardamom, nutmeg, and umbelliferous fruits. The size of a starch grain is also important in detection of adulterants. In case of cinnamon, cassia, the diameter of starch grains is usually more than 10 microns. The dimension of fibers also helps in detecting adulteration in case of cinnamon. The number of sclerenchymatous cells per square centimeter in cardamom is one of the criteria for detection of varieties of cardamom seed in powdered form. The percentage purity of an authentic powder ginger is calculated using the following equation. Percentage purity is equal to N into W into 94 thousandths into 100 divided by S into M into P, whereas N is equal to the number of characteristic structures in bracket example starch grains bracket complete in 25 fields, then W is equal to weight in mg of Lycopodium taken, S is equal to number of Lycopodium spores in the same 25 fields, M is equal to weight in mg of the sample calculated on the basis of sample dried at 105 degrees Celsius. P is equal to 2,86,000 in case of ginger starch grains powders. Thank you.